Hello guys, this is gonna be the last lecture for this semester. I'm gonna go over homework 24 and finish the homework 24 for you, which is over here. And I'm gonna open, we're gonna continue exactly where we stopped last time. So here you go. And we're gonna start with number 11 is the one we're gonna finish today. And number 11, it says, use the table on the right to find the indicated probability events A, B, and C are mutually exclusive events. D, E, and F. So what that means, if they're mutually exclusive events, that means they don't have the interception between them is 0. So here what we need to find is the probability of B. So in this table, you have the events A, B, C, and D, E, and F. So probability of B, because we know they're mutually exclusive, it's going to be just adding all these probabilities. And we actually have the total. So the probability of event B is going to be just adding all this column. And the answer should be 0.11. They give me the probability, so just we got that one. Okay. The next question is number, I think is number 12. So here we have to find the probability of interception between B and E. So I have B, so we're going to look at the column B, and then we're going to look at the row E, and whatever they intercept and the number there is going to be the probability of event B intercepting with event E. So in this case, the number we have there is 0.26. So that's what we're going to get there, 0.26. Okay, and that was good. Then going to the next one. Here we have to find the probability of D knowing C using this formula. And we are using the table on the right side. So here, we're just going to use the formula. So we have probability of D intercepting C. So it's going to be D and C intercepting, which is going to be 0.10. So we have 0.10 divided by probability of C, which is the total here, 0.40. So when you reduce that, it's going to be 1/4. And in decimal form, it's going to be 0.25. So that's what I'm going to put for the answer, 0.25. And that was right. Going to the next one. So here we have to do pretty much the same. So they give me, we have to find the probability of B knowing D using that formula. So here we have probability of B intercepting D. B and D intercepting is right here, which is 0.15, divided by probability of D, which is 0.60. And we're just going to divide those two numbers. So we can just divide 15 divided by 60. It's going to be 0.25 also. And let's check the answer. Okay, that was good. And then going to the next one. So we have this given table. So we know that events B and E are independent based on the following table. So we have to test. Okay, no, I'm sorry. We have to test the pair B and E if they're independent or not. That's what you have to test. And two events are independent if We have B and E, so I'm going to write the formula for B and E. So two events are independent if probability of A intercept, I'm sorry, B, we have B here, B intercept to T is equal to probability of E, sorry, B multiplied by probability of E. So we're going to check that. This is the formula we're going to use to check. So let's see, what is the probability of a B intercepting E? So we're going to look at B and E, it's 0.05. It's right here from the table where B, column B and row E intercept is 0.0. So the number here is 0.05 equals, what is the probability of B? Let me use different colors. So probability of B is this number, the total, 0.5, times probability of E is this total here, 0.1, 0.10. So when I multiply those two numbers, it's going to be exactly 0.05. So those two numbers are the same, 0.05 equals 0.05. So that means those two events, B and E, they're independent. So let's see which one you're going to pick. And B are dependent, they're independent, so it's going to be one of B or C or D. B and E independent because they're equals. They're not equals, they should be equals. So the answer should be D, because the events are independent. Because two events are independent if those two numbers are the same. Sorry, G is the right answer. And we're going to fill out probability of, so both of those probability are going to be 0.05. Okay, so we get the same probability, and that's why they're independent. Okay, and let me go to the next one. And here we have pretty much with the same question. So we're going to check for independence, but here we're using A and D. So if I have A and D, I'm going to write the formula probability of A intercept with D, because those are the two events given, equals, they should be equals, if they equal, they're independent, equals probability of A multiplied by probability of D. So let's see what are the numbers here. So probability of A intercept with D. So I'm going to look at A and D. They intercepted. This is the interception. So you have the row for D and the column for A is 0.18. And then let's see the other side. We're going to check it if they're the same. So you have probability of A is 0.5, 0.50, which is the same. Multiplied by probability of D, it's 0.30. Now, when I multiply 0.50 times 0.30, I get 0.15. So they're not the same. So when I multiply those two, I get 0.15. So that means they're not independent. So those two events are dependent, one of those two answers, because actually D is going to be the answer, because does not equal, because those two sides of this equation does not equal. Okay, so the probability of A intercepting D was 0.18, and probability of A multiplied by probability of D, and D is 0.15. They're not equals. Okay, so that's should be my answer, and that was right. Okay, going to the next one. Let me clear this so I can see. Okay, so here we have to check again, are those events independent? So pretty much we're doing the same. So we have this table, we have to, I'm gonna write the equation for C and E. These are the two events I'm gonna check. So the formula is gonna be probability of interception. So we have C intercept with E equals probability of C multiplied by probability of E. So now let's look at the numbers. So this is the formula. So looking at the number C intercept with D. So we have C's here and D is the first row. So the intercept over here. So it's going to be 0.01 is the number in the left side of the equation. And we're going to check, is that equal to probability of C? So in this case is the number here, 0.10 multiplied by probability of D is also 0.10. So when I multiply those two, 0.10 times 0.10, that's also going to be 0.01. So those two sides of the equations are the same. And because they're the same, those two events are independent. So the answer should be yes, they're independent, because those two numbers are equals. Okay, that was good. And let's see what is the next one. We have, let's read that. We have number 18. So we have automotive manufacturer produce 35% of its cars at plant A. If 6% of the cars manufactured at plant A have defective emissions control devices, what is the probability that one of these manufacturer's cars was manufactured at plant A and has a defective emission control device? So we have to find the probability here. So here we're going to look at the keywords here. We have to find, let's see the question. What is the probability that one of these markers was manufactured at plant A and has defective emission? Okay, so here we're going to say, let's say event A is the car is produced in a plant A, and let's say B is the event when the car has defective emission control device. Okay, so here what they're asking is to find probability of A and B. So it's going to be and is like interception of B. So how are you going to find that? So the formula to do that is going to be it's multiplying the probability of control device. So we have given 35 plant A. So you have probability of A. Actually, in this case, it's going to be B, knowing A, multiplied by probability of A. So we're going to multiply technically the probability 35% and 6%. So 35% in decimal is going to be 0.35. We're going to multiply by 0.06. And when I multiply that, those two numbers, 0.06, that gives me 0.021. So let's put the whole everything. Let's see, 0.02. Okay, I think we have to put everything. 0.35 multiplying by 0.06, 0.21. Let's just put everything here. Okay, so that's right. So here what they want, they don't want to round the number. See, I round the number to 0.2 to decimal, so it says wrong. So be careful when you submit this question. When you do this question, be careful. You're gonna put everything you get. See, 0.21 was right. 0.02 was wrong. So make sure you put everything the way it is, okay? And I'm gonna go to the next one. And the next one is, it's another one. So we have, so let's see, we have, if a salesperson has gross sales of over 600,000 in a year, then he or she is eligible to play a company's bonus game. A black box contain, so let me underline, this is important, two $1 bill, one $5 bill, so you have two, one, and one $20 bill. Bills are drawn out of a box one at a time without replacing with until a $20 bill is drawn. Then the game stops. Then salesperson bonus is 1,000 times the value of the bills drawn. Complete the part 1 through C. So let's see what we have. What is the probability of winning a 26,000 bonus? So here we have to find what is the probability. So we have two, what are the outcomes? Two $1 plus 1 5 and 1 20, so that's 4, right? So should be 1 out of 4. Okay, so let's try that again. We have let's see what we have. Okay, so I just deleted that question, and then we're gonna go to the next one. So we're gonna have the next one. It says find the expected value. So we have given in this table, we have given different outcomes, x1 or xi. So these are 3 outcomes, -3, 2, and 6. Each of those outcomes has probability pi, which is 0.3, 0.4, 0.3. And they're asking you to find the expected value of x. So the expected value is when you multiply pretty much this time this, this time this, and this time this, and you add it together. So I'm gonna write it -3 times 0.3 plus, it's always adding it, plus 2 times 0.4 plus 6 times 0.3. And you can use symbol up to do that, like calculator. I'm just gonna do it. So it's gonna be, so here we have -0.9. We have plus 0.8 plus 1.8. So when I do that, adding 0.8 and subtracting 0.9, that's gonna be 1.7. Come on now, 1.7. So that's the expected value. So the expected value is gonna be the number you get when you calculate that, okay? And so you multiply x times probability. Each outcome, you multiply the probability of that, and then you add it together. The next question is this one. So here we have, you draw and keep a single bill from a hat that contains 1, 5, 20, and $50 bill. What is the expected value of the game to you? So here we have find the probability of to getting $1, $5, $20, and $50. So all of those probability, because we have 1, 2, 3, 4, they're 4 integer. So I'm gonna answer it like an integer. So they have the probability to get 1 is gonna be 1 over 4. And the same way for all of those. So because there are 4 different bills, probability of each of those is going to be 1/4 because there are 4, each of those have probability 1/4. So it's going to be 1/4, 1/4, 1/4. They have equal probability, okay? And then the next question is, what is the expected value? So finding the expected value, we're just going to do the same. Multiply each outcome by the value of the probability by the value of the dollar amount. And then you're going to add them. And that's going to be the expected value. So we're going to multiply $1 times 1/4 plus $5 times 1/4 plus $20 times 1/4 probability, and then plus $50 times 1/4 probability. Now, because when you multiply those, it's going to be averaging over 4. So I have to add 1 plus 5 plus 20 plus 50. And we're adding those because 1 times 1/4 is 1/4. 5 times 1/4 is 5/4. So that's how you get these numbers. And you're just going to add 70. So we have 76 over 4. And what do we want? How they want integer or a decimal. So we have to go to decimal. So 76 divided by 4 is going to be $19. Okay, so let's check that. Okay, that's right. So 76 divided by 4 give me 19. Okay, and that's how you do this. That's how you do the expected value for this question. Let's do the next one. So here we have, I don't know if I can make it bigger. Yeah, let's do that. I'm gonna make it a little bigger. So you draw and keep a single coin from a bowl that contains 17 pennies. So let's see what we have. So we have 17 pennies. 17 times 0.0, that's the value, 1 cent, right? We have 11 dimes. Each dime is 10 cents, right? And 22 quarters, which is 25 cents. What is the expected value of the game to you? So first you have to calculate the probability. So I'm going to make the little table. So because they're different amount, so you have here is the X, the outcome, and here's the probability. So the outcomes are going to be a penny, which is 1 cent. We have also, they want the answer in dollar amount, so I have to be careful with that. Yeah. We have 10 cents and we have 25 cents. Now, what is the probability? So when you add those 3 numbers, we add in 22 plus 11 plus 17, that's 50. So the probability to get a penny is going to be 17 over 15. And I'm going to keep it as a fraction now, and then I'll change it. Then probability to get a dime is going to be how many dimes you have? 11 over 50. And then the quarters are going to be 22 quarters out of 50. And I'm going to keep it like that. And then we're going to find the expected value. So we're multiplying those 2 and those 2 and those 2, and you're going to add them together. Okay, so that's how you're going to calculate that. Okay, so I'm going to use here, I'm going to use symbol up to calculate it. And I'm going to go symbol up, and I'm just going to put 0.01. I'm going to multiply by 17 out of 50. Oops, sorry. Okay, 0.01 times 17 out of 50. And I need to get out plus, I'm just gonna put it like that, everything together. 0.10 times 11 over 50. Oops. And then I need to get out of that fraction plus 0.25 times 22 over 50. And let's see what you're gonna get. We're gonna get the dollar amount. So it's let me write it here, 0.1354. And going back to the question, 3 decimal places, that's what I wanted to see. 3 decimal places is going to be 0.135. And that was good. Okay. So that's how you do the expected value. Okay, the next one is another one like that for the expected value. So we have unfair coin is flipped. So that means it's not 50-50 probability. If the head turns up, you win $1. If a tail turns up, you lose $1. The probability of head is 0.42 and the probability of tail is 0.58. What is the expected value of the game? So here we have given to win $1. It's a head, so it's going to be, the probability is 0.42. And the other one is going to be 0.58. And if you notice, both of those numbers add up to 1. So always when you have events like that, all the outcomes for X, they add up to 1. And then you have to find the expected value. So we're doing the same. We're going to multiply this time this. We're going to add it with this time this. Okay, so we're going to have $1 times 0.42 plus, I'm going to write it like this, negative $1 times 0.58. And then technically you have 0.42 minus 0.58 is going to be negative. So what is 0.42 minus 0.58 is 0.16. Okay, so let's check that. Minus 0.16. And that was right. Okay. Going to the next one. So here we have another one, unfair coin. So if the head turns up, you win $1. If the tail turns up, you lose $1. So still we have pretty much similar situation. So we have, so these are the outcomes. You're winning $1 and you're losing $1. Now the probability of, so down here, I'm gonna put the probability of head is gonna be 0.36 and the probability of tail is 0.64. And you're doing the same. And we're gonna get technically you just have to multiply those and you actually do 0.36 minus 0.64 is gonna be negative 0.28. You technically subtract those two numbers, 0.36 minus 0.64. And that was good, that was right. And then going to the next one. Next question, we have the payoff table for two courses of action A1 or A2. So I have it here, A1 and A2 is given to the right. So this is the table given. Which of the two actions will produce the greatest expected value? And what is the expected value? So what you need to do, you need to calculate, you have to calculate the expected value for option 1. So that means, so let's do action 1. You multiply this time this time this, and so on, and you add them. So you have 0.2 times negative 400 plus 0.1 times 100, and then plus 0.1 times 100 plus 0.6 times 400. So I'm going to use symbol up again. We have 0.2. Let me clear a little bit so I can see. 0.2 negative 400, 0.1 is 100, and the other one is 400. Okay, so let's go to symbol up. I'm going to use the symbol up again it's faster that way. So I have 0.2 times negative 400 plus, it's always plus, 0.1 times 100 plus 0.1 times 100, and then plus 0.6 times 400. And that gives me 180. So get 180. And then, see, 180 is down here. And then let's go ahead and see the action 2. I'm going to use different code for action 2. So action 2, we have the probabilities using now this times this. So it's going to be action 2, we're going to have 0.2 times negative 200 plus 0.1 times 400, and then plus 0.1 times 500, and plus 0.6 times 400. So this is what I'm gonna plug it in on WebAssign. So we have, so I'm just gonna change this to negative 200, and then we have 400, and then 500, and then 0.6 times 400. So this stayed the same. And here we're gonna get, what we got is 290. 290. Okay, so going back to the question. So the question is, which one, action 1 or action 2, is gonna produce larger expected value? Obviously A2, action 2, because it's, what is it? 290. Because 290 is bigger than 180. Okay, so that's how you do those. Okay, so that was the question. And then going to the next one, we have another expected value. And here we have 5,000 tickets are sold for at $1 each. Tickets to be drawn at random, and monetary price award as follow. So I have one prize. So let's write here. So So we have one price, 800, three prices of 100, five prices of 20, and 20 prices of $5. What is the expected value of this raffle if you buy one ticket? So X is the random variable for the amount won up a single raffle ticket. So let's make the table first. So we have, so these are the X's, and we're gonna find the probability down here, and we're gonna find the expected value. So let's see, we have one price of 800. So that's gonna be, because you're gonna pay for one ticket. So it's gonna be losing one ticket, right? $1. So one price of 800, so it's gonna be $7.99. Find the probability. Three prices of 100, so it's gonna be $99. $20, so it's gonna be $19. And $5 is the price, is gonna be $4. Because you have also, you're gonna pay $1. That's what you have to keep in mind. You have to include that $1 you're paying to buy the ticket, okay? So let's calculate the probability. Now, there are 5,000 tickets sold, right? So we have one price of this, so it's gonna be 1 out of 5,000, okay? Then we have 3 out of 5,000. How many? $20. So it's gonna be 5 out of 5,000. And for $5 of 20. 5,000. And then we're gonna calculate the probability of to buy that to actually in this case, the last case when you have -1 is just losing. So you're buying a ticket, raffle ticket, but you don't win anything. So we're gonna find the probability of this is gonna be when I add 1 plus 3 plus 5 plus 20 and subtract from 5,000. So 29 is the probability to win something because you're adding 20 plus 5, 25, 28, 29. And when I subtract from 5,000, so actually the probability to win nothing is gonna be 4,971 out of 5,000. Oh, sorry, I put extra zero here. Okay, so now let's calculate the expected value. So we're gonna multiply each of those, and then I'm gonna plug it into the symbol app calculator. And we're gonna have, I'm just gonna use fraction for probability. So I have 799 multiplied by 1 over 5,000. And then we have plus 99 multiplied by 3 over 5,000. And then plus 19 times 5 over 5,000. I'm just going to put it like that. I'm not simplifying. The calculator is going to take care of it. So I have, plus 4 times 20 over 5,000. And then minus, I'm going to put -1 because plus negative is minus. 4,971 over 5,000. And then let's see what you get. What is the expected value? So we're going to get the decimal, it's negative 0.74. And let's go ahead and check that. Negative 0.74. Okay, so that was good. Let's go ahead and see what is the next one. Next one is another expected value. So we have here 1,000 raffle tickets sold, $1 each. So pretty much the same one. 1,003 tickets will be drawn at random. So here we without replacement, and each will pay 202. Suppose you buy 5 tickets. A, create a payoff table for 0, 1, 2, 3, 4 winning tickets. Also here we're gonna draw 5 times technically. You purchase, and then if you do not have any winning tickets, you lose $5. If you have 1 winning ticket, you net $197, since your initial $5 will not be returned to you, and so on. Okay, so this is the amount, and let X is the random variable to the amount won in a single raffle tickets. So we have to create this table, and we have to calculate the probability for that, for each of the outcomes. Okay, so I deleted 27 also, and we're gonna go and finish the last question is 28. So suppose that at each birth, having a girl is not as likely as having a boy, and the probability assignments for the number of boys in a 3-child family approximately empirically from the past records and are given in a table. So this is the table of number of boys in a family. What is the expected number of boys in a 3-child family? So here we have the outcomes, so to have 0 boys, to have 1 boy, 2 boys, 3 boys, right? Because they have 3 childs, and these are the probability given on the second column. So the expected number of boys in 3 family is so the expected value. So pretty much we're calculating the expected value for this one. So we are multiplying X times probability of that, each of those, and you're adding them. Okay, so it's gonna be 0 times 0.11 is gonna be 0. I mean, I'm gonna write it like that, but technically it's 0, plus 1 times 0.35 plus 2 times 0.36 and plus 3 times 0.18. Excuse me. Okay, and then you're gonna calculate that. I mean, this 0 times 0.11 is just 0, so I'm not gonna put it in the calculator because 0 plus anything is 0, and then I'm gonna go to the calculator, symbol up, and I'm gonna plug it in. So I have 1 times 0.33 is 0.35. I'm sorry, 1 times 0.35 is 0.35 plus 2 times 0.36 and then plus 3 times 0.18. And we got the expected number is 1.61. So we're going to keep it exactly like that, 1.61. And that was the right answer. So this is what the homework include for this week. If you have questions, you can ask me after you finish the video. Thank you, guys.